Good afternoon. Today I'm going to rasterize a large GDSII file. As you can see on the screen, this is a 300 millimeter wafer that has had a very large number of RDL circuits that have been arrayed on it. You can see the circuits are quite dense. That little line there is 2 microns, so you get an idea of the line widths there. You see this has all angle data. It has some nice filters. Those are 4 micron interdigitated filters. If we turn off the fill, what you can also see is that it has been sliced in order to produce the correct data. Some of these polygons have as many as 3,000 sides on them because these circles are approximated with many, many small vertices. So it's a pretty challenging layout. We're going to rasterize a strip that is 300 millimeters wide, that is across the center of the wafer, and it's going to be 4 millimeters tall. We're going to rasterize that with a pixel size of 200 nanometers, or 0.2 micron. It's going to generate a raw bitmap that would be 3.75 gigabytes. Our program will actually compress that using run length encoding. Hopefully we get something that's at least 10 times smaller. The program I'm going to use is Artwork's NextGen raster. In order to run this program, we provide a little command line engine that calls the library. I call the engine and I give it the input file I want to process. I tell it the output can be called stripe. I tell it to process layer 1 and to use a pixel size of 0.2 micron. To use 4 threads on this machine. To output TIFF, and our TIFF by default is packed bits encoded. Here I've specified my window, which you can see is minus 150 to 150, so that's 300,000 microns, and minus 2,000 to 2,000, which is 4 millimeters, and I ask for a log file. Now let's look at the hardware. You can see I'm running an i7 core, and it's running at about 3 gigahertz clock speed, and I've got 12 gigabytes installed running Windows 7 64-bit operating system. So let's execute this and see what happens. Alright, some output to the console. And the file's actually being written now, and most of the time spent was actually in writing the file, and that's due to the fact that I have only a standard spinning hard drive on this machine. To take a look at very large bitmaps, we developed our own bitmap viewer because we couldn't find one that did what we needed. I'm going to select the file we just created. Now I'm going to zoom in, small area here. So let's really get in there and see what we got. You can see, since we have 2 micron line here, that because our pixel is 0.2 micron, we have enough pixels to really image the line very cleanly. Now I've opened the log file, and you can see some things here about the file. You know, it loads the file. So you can see it took 8.74 seconds, and that actually includes the disk I/O. This is certainly not the fastest machine, and we haven't taken advantage of a large number of cores. I would say, in terms of reaching our goal of 4 seconds, it's certainly doable.